to 6-4. Yeah, our memories were a little bit problematic there. But I think when we're talking about composites, because that was within the last week and a half, that might not be so bad. So this says find the composite function for f of x equals negative 2x plus 6 and g of x equals x squared plus 7. And they want us to find g of f of x. And again, I would rewrite that to show myself, okay, this is the one that's inside. Always work innermost parentheses and go out. And so that shows we have to take f of x and we have to put it into g of x. Do you remember where we put it? This has to go someplace in there. Where does it go? X, yeah, the input. So this goes right there. And it will become negative 2x plus 6 squared plus 7. And then we have to do the math. So can we distribute that power of 2? People are shaking their heads. No, which is good. No, we can't because there's addition in here. So we're going to have to take negative 2x plus 6 times the quantity negative 2x plus 6. And then at the very end, add the 7. So let's see what we get. First times first will be 4x squared. Should put my equals on all of those. And then outside times outside would be minus 12x, but so would inside times inside. So together that would give us minus 24x, and last times last would be plus 36, and then we just need to add 7, and then we've got it. So 4x squared minus 24x plus an obnoxious little 43. We don't have to do anything with it, which is kind of nice. It's just find the composite. Didn't even ask about domain or anything like that. It's plug it in, see what you can get. Alrighty. That will probably make 14 easier. So which one's going into which one for 14? G's going into F. So that has to go there. Now that's a dangerous problem. Do you see why? There's a negative in front. Negative of x minus 7, the quantity x minus 7 plus 3. So we absolutely want to distribute that negative and then combine like terms. And that, again, it's one of the most missteps on this test is people forgetting, oh, I've got to distribute the negative through the whole thing and then put it together. So, okay with composition? Jackson? The order is the same as it is up here because it's saying you're going to take G, but only after you find f of x. What's closest to those parentheses, that's the one you have to do first. So we start with that innermost function. So it's f of x plugged into g of x. Yes, it's kind of backwards. It feels backwards. And that's why I think it's important to have it in the parentheses so you know this is the one that has to go into this one. Make sense? Okay. Anybody else? Anything about the composition problems? Jordan, question? No? Alrighty. Let's go on. Well, this is interesting. Let f of x equal 2x minus 7 and g of x equals x squared plus 2. Find the value of the composition. This is different. Why is it different? We're going to find a negative 3. It should be easier because then we remember, all right, so this is outside, this is inside. I have to start by putting negative 3 into G, see what I get, and then plug it into F. Innermost parentheses out, always. So let's see what G of negative 3 is. G of negative 3 will be negative 3 squared plus 2. Remember, you don't do any math over there with the G. Only on the right-hand side. Negative 3 squared? 9. 9 plus 2? Now, we're more than halfway there, but we still have something we have to do, because once we had this answer, we have to put it into f. So now we need f of 11. Two times 11. 22 minus 7. 15. There's our answer. So we want to put a box or a big circle around that so that it shows, hey, we knew to put it into G first and figure out what it was. It was 11. Then we put it into F, and we got 15. And we're done. This was a value. So when it said find the value, light bulb comes on. Wait a second. That's not a formula like the ones we just did. That's an answer. We're going to find an answer. Alrighty. Inverses, even fresher in our minds. Find the inverse of each function. Is the inverse of function yes or no, and explain. Well, let's just start with finding the inverse of the function. What's the first step to finding an inverse? Switch the x and the y, and this is y. So we need to switch those. Okay, Jackson, you're a step ahead. Now square it. Square both sides. Question? Everybody's good? Okay, so that took care of step 1, right? Step 2, what is it? Yeah, so, we did the squaring piece, but y is not by itself yet. So what do? Subtract 16. So x squared, ooh, I'm running into my spaces down here. Am I going to have room? I will just write it right here where it says inverse. X squared minus 16 equals, and you could use y. I'm going to use the fancy f inverse since it said inverse, but you absolutely could use y. I'll give you full credit for y. So let's see. Is the inverse a function? If I put one number in, do I just get one out? How do we know if we're not going to? Good, a plus or minus. People are remembering that. So this is a function. Yes. And explain. If we put one number in, we get one number out. Yeah, I think I'd take that. Yeah. If we put one number in, we get one number out. Yeah, because that says you know what you're doing too. With the plus or minus, there's two outputs, so it says the same thing basically. Alrighty. So how would you start 17? Make a y. Okay, I made a y. Then switch the x and the y. Add 7. Square root. Uh-oh, what does square root do? Plus or minus. And again, you could leave it y if you want to. I'm going to put plus or minus the square root of x plus 7, if I can fit that in there, equals f inverse, but I'll take y. Function? No. Every input has how many outputs in this one? 2 of them. Now, here's what I wouldn't want, Jackson. I wouldn't want plus or minus as answers for both of those. At least one of them should explain how we know it's not a function. So if you did plus or minus over here, no plus or minus over here, then something about how the input has 2 outputs over there is really, that's the definition of a function. Going to be okay with those? Looking good? Okay. Ooh, graphing. We were really good at this. Alrighty, analyze the transformation, graph the parent function and transformed function, find the domain and range of the transformed function. Oh, where to start? Well, it said analyze the transformation, and I'm sure there's spots down here. Domain, range, describe the shift. Okay, so let's take a peek at it. y equals negative square root of x minus 2 minus 3. What should we take for our table? Negative square root of x. It's always a square roots of x. Some good numbers for square root? 0, 1, 4, 9. Yeah, those are our go-tos. There's an extra spot, but we don't have to use it. If we have at least 3 points, we're going to be good. Alrighty, so if we put 0 in here, is there such a thing as a negative 0? It's going to be 0. Put a 1 in. What do we get? Negative 1, because we still have that negative in front. Put a 4 in. Negative 2. Put a 9 in. That would drive me nuts that there's one blank there. I know I'm not going to graph it, but I'd put 16, negative 4. I just would drive me bonkers that there's a square that I haven't filled out in there. So, what should we do with that? Graph it. Solid? This is our dashed or dotted. 0, 0, 1, negative 1. Hey, it's going down. Is it supposed to do that? Why? What tells you that it's supposed to go down? Yeah, it had a negative in front. It's going to reflect over the x-axis. All right, so I got that little hummer going. And then I need to figure out where to move it to. Where's this one go? Right 2 and down 3. So remember, it's a square roots of x minus h plus k. There's actually a slot down there for the shift for us to write 2 to the right and 3 down. There we go. And then we just go up and count 2 to the right and 3 down for all of our wonderful little spots we had there. I have to go a little bit off the grid for the 9, negative 3 over there. Now when I see domain and range, I start thinking, I better figure out what this new starting place was right here, because that's going to tell me my domain and range. What's the new starting place? 2, negative 3. 2 to the right, 3 down. All right, domain, that's the x's. Which of those two numbers is an x value? The 2. We're going to the right forever, so what should we put in there? Greater than or equal to. Bigger numbers are over there for the x's. Range, well, that leaves negative 3 for that, right? Okay, we're going to be above it for greater than or below it for less than? So then we need less than or equal to, because this one had a negative. That's a lot of steps. And even though, you know, you're really good at this, it's one of those things where there's a lot of points that come from graphing, because there's a lot we have to see. Because if I don't see this dashed graph right here, you don't get any points at all. We all know we can graph these on the graphing calculator. You're not getting points for that. You have to show me, hey, that's the parent. This is the shifted graph. So all of those things will get you points. Alrighty, that was a square root. This one is a cubic root. All right, what should we use for our parent? Just cubed root of x? That's all we have, yeah. If there were a number in front of it, there is a 1, by the way, but if there were a number in front of it, we'd have to take that with. All right, this time the xy table I don't think is big enough. Do you remember the numbers we used for this one? Negative 8, negative 1, 0, 1, 8. Oh, just big enough, huh? Just enough. And with this one, it's just cubed root. So cubed root of negative 8. Negative 2, cubed root of negative 1. All right, I know what you're doing. You're writing it and you're not talking to me. That's okay, as long as you know what they are. Now what? Yeah, let's make our dashed or dotted. bad. Next thing we would want to do would be describe the shift. I bet there's a little spot down there, even though I can't see that, for describing the shift. Where's this one going to go? Right one, up 3. Good. Bless you. And then we go and do that. We move our 5 very nice little points, right 1 and up 3. Beautiful. Not quite done, but we kind of are, right? What's domain and range for these? Yeah, all of us. No thinking involved. Going forever, right and left, up and down. There it is. Got it. You're going to bust this test up on the graphs. Okay, so this is where the video stopped. And what we would want to do is factor out the square root of 16. And by factoring out, we mean divide. So 16x divided by 16 is x, and negative 32 divided by 16 is negative 2. Then we do know the square root of 16, it's 4. And then finally, on the test, we're probably going to ask you to describe all the transformations. So you'd start by saying the parent function is the square root of x. We have a vertical stretch, factor of 4. And that's from the 4 that's in the front. And then we talk about the translations, and this one would be translated 2 to the right and 8 up. And that finishes up the practice test.